Well, welcome students to our next session here. I just want to start off by encouraging you guys that, hey, put the work in, show up, watch the videos, take the notes carefully, and graduate. Get your diploma or whatever your degree is that you're pursuing. But this is worth the time. So I just want to really start off with a little bit of word of encouragement that this is going to pay off big time for you. Don't skip any steps, and make sure that you just take good notes, take your time, do the problems carefully, and you'll do great. We have this session, which we're going to be talking about squares and square roots, and also we'll be talking about the Pythagorean theorem soon here. And then next section we'll review for your second exam. Okay. All right, let's jump in. Go ahead and pause the recording, and take the notes on the screen, and I will jump into here and see how we can do here on squares and square roots. All right, I hope you're ready. So squares and square roots. This is kind of a very important concept that's going to help us on our next kind of when we start getting into the Pythagorean theorem. Okay. And so let me do this. Let me just pull this over just a bit here for us. Okay. Hopefully that'll show up better. Okay. So squares and square roots. Squares, I have this number at the top of the screen here underneath squares and square roots. This is number 5 here. Okay. 5 squared, this little 2 is called an exponent. You might remember that from math back in the day. And the number 5 itself is, we call it the base number. But the key here is we're looking at this 2, which means squared. Okay. So what squares mean is that number, whatever that number is, the base number, is multiplied by itself one time. Okay. And so one time it is multiplied times itself. And if I give you examples below, 2 squared, so here's my examples. 2 squared, see that little 2 up there, that means times itself one time, is 4. 4 squared is 16. 5 squared is 25. Okay. And if I ask you what's the value of x squared, if x is 7, like in my green post-it note here, if x is 7, what's the value of x squared? 7 times 7 is 49. Okay. You actually have a page in your book. If I draw my arrow here in the bottom left of the screen here, the table of perfect squares is on page 63. And so the reason why I want to point your attention to that is that's kind of a fast reference for squares of numbers. Like let's say you had the number 144 and you're wondering what's the square of that. On that table, it'll say, oh, it's 12 squared. And so that's a fast reference, is page 63 for doing your homework. And you can use that on the exam as well to help you. So there is a way to do it quickly on a calculator, but everybody's calculator is different. So you'd have to look your calculator up on YouTube and see how to do that. All right. Now, what is the value of these? I'm over here in the top right of my screen. 9 squared. If you know your times tables, you remember that 9 times 9 is 81. So that would be the value of 9 squared. Okay. And again, you can look at this table 63 and just look at 81. Look at 9 squared and it'll tell you that it's 81. 4 squared is 16. 8 squared is 64. And let's look at this problem here at the bottom of this. It says x squared. What is the value of x squared if x is 9? Well, that just means 9 squared, right? We're saying if x here, x is 9 or equals 9, it equals 9 squared equals 81. Okay. So anyway, so if x is 9 and it's squared, it's 81. All right, let's take a look at our next slide here and see how we do here. The next concept. All right, we're also going to talk about square roots. So go ahead and pause the recording, copy down what's on the screen, and then press play. All right, square roots. So a square root is, you're asking this question right here on the screen here. What number times itself equals this number? Okay. So if my examples on the bottom left, okay, the square root, and by the way, that's the square root symbol. It's you're asking for the square root of something. If it asks what's the square root of 4, well, what number times itself equals 4? 2. Okay. If you see the square root symbol 16, and you're asked what's the square root of 16, you're asking what number times itself equals 16? Well, that's 4. What's the square root of 25? 5. Okay. Um, Note, you can use a calculator to find the square root of any number, like what's the square root of 13? And that's not a perfect square root because that's going to be, you're going to have decimals in there. But you can YouTube your calculator. You probably have to use YouTube to actually punch in your calculator, watch a 2-minute video showing you how to find the square root. However, for you guys in this class, I think most of what you're going to need is on that page. What I say, 63, 62 or 63. All those square roots are right there. Okay. A's square root of 64 is 8 times 8 is 64, right? So that's 60. That's it. A is 8. Okay. Square root of 36. Again, 6. Square root of 49, 7. Square root of 100, 10 times 10 is 100. Okay. All right. I want you to pause this recording and do all the problems on pages 62 and 63 before continuing. All right. I hope you're ready. Now we're going to jump into something called the Pythagorean Theorem. Okay. So first, pause this, copy everything on the screen, and I will make a few adjustments here and start in about 5 seconds. Okay. So, okay. Here we go. First, I want to talk about the Greeks. There was a guy by the name of Pythagoras, an ancient Greek character who was a mathematician, and he started looking at specifically right triangles. Okay. He started discovering some magic about right triangles. And if you'll recall, a right triangle has a 90-degree angle, like my triangle here on the screen. They have a 90-degree angle, and he found out kind of a mathematical formula which they actually use in engineering. They use it in building. I used it to put wood flooring in my house in order to get perfectly perpendicular straight lines to line up where the wood flooring would be. And what he found was in a right triangle. By the way, if you look at my triangle here on the right here, this it's a right triangle. And typically you will see this long side of the triangle, the one that's opposite the 90 degree. They call that the hypotenuse. I'll say that again, hypotenuse. Okay. Good idea to say it out loud, by the way. Just it's a good way to learn words. But hypotenuse is the long side of a right triangle, which is opposite the actual 90-degree angle. Okay. And so he came up with this formula, and this formula here on the left is a squared plus b squared equals c squared. Okay, let's talk about what that means. In my triangle, I've got a side A, okay, that runs this direction, got a side B that runs up north and south here, up and down. And those are sides, okay? And then I have side C, which is my hypotenuse. And so what that means, what he just explained in his theorem, is that if I square A and add that to the square of B, that will give me C squared, okay? So again, I'll say that again. If I square A, if I line up my formula, whatever A is, say it's 3. If I square that and get 9, and let's say that B was 5, and I square that and get 25, 9 plus 25 gives me 24, which would be the C squared. Okay. And so if I found the square root of C, I'm finding out what C actually is, its length. Okay. Let's take a look at the sample question at the bottom of the screen. What is the length of the hypotenuse of the triangle to the right? Okay. So what you've got is a triangle. It's got a side A. I'll put a letter here. It's got a side B, put a letter here, and it's already got a side C, okay, which is the hypotenuse. All right. This is exactly the way I want you to do this on your own paper in your homework and for the test. And I want to reemphasize, slow down, do it one step at a time, don't get in a hurry, and you're far likely to actually go faster and get the answer correct. Okay. So over here to the right, on the bottom right of the screen, here's how I want you to write these out. I want you to rewrite out the formula. A squared plus B squared equals C squared. Then I want you to plug the numbers into it. Okay. A is 6. Okay. So there's my 6 right there. Plus B is 8 squared equals C squared. Then I want you to, okay, if I square 6, it's 36 plus the square of 8 is 64 equals C squared would um, be 100. Okay. Now, how do I know that? If I add 64 and 36, it gives me 100. Okay, so if you're wondering where did this 100 magically appear from, um, I'm adding 36 plus 64 gives me 100. Okay, so C equals, okay, now I'm going to slow down a little bit here. C therefore equals the square root, because remember, we said that A squared plus B squared is C squared. So this 100 is C, whatever that length is, squared. Okay, so times itself. Okay, so if we find the square root of it, okay, so C equals the square root. I'm on the bottom right here again. C equals the square root of 100. Well, I know that 10 times 10 goes into 100, or you could look at page 62 or 63 and see that 10 squared is 100. Okay, so length C, side C is, and by the way, some math teachers really like you to write out the dimensions. In this case, it's yards. We're talking about yards, is 10 yards, okay, um, in length. So I want you to stop the video and complete the problems on page 65 of your textbook before moving on to my next slides. Okay, I have another problem, sample problem here. Sample problem 2. What is the length of the unmeasured side of the right of the triangle to the right here? Okay, so I'm talking about this triangle on my right here. First thing I want to notice is that, okay, yes, this is a right triangle. Okay, in Pythagoras, my theorem, a squared plus b squared equals c squared. All right. Now, you're going to notice that this one's a little bit different than the one we previously did, because the previous one gave us a and b, but it didn't give us the c squared, that length. However, this one gives us the hypotenuse, but doesn't give us a, but it gives us b. Okay. So what I've written down here in the bottom of the screen is, here's another way to set it up, which is how I would set this up. And this is how I want you to do it. If you get a Pythagorean theorem triangle that's a right triangle, and they're asking you to figure out what A or B is, and they've given you C, write it out like I've done here in the bottom right here. Right, C squared, because they've given you that, equals A squared plus B squared. It'll just make it a little bit easier. It's the same as saying a squared plus b squared equals c squared. It's just that it's lining up in a way that'll kind of make sense with what you've already been given. Okay. So again, slow down and write the whole formula out, just like I did. Okay. That way you're going to follow down the line, down the row, step by step. So I've got c squared equals a squared plus b squared. Write it on your paper. And then go, okay, what's c squared? Well, that's 5 squared plus a squared plus 4 squared. Okay. Now, a squared, remember, a is here. They didn't give that to us. But b, they gave that to us. They said it's 4. Okay. This b is 4, whatever it is, feet in this case. Okay. So that's 5 squared plus a squared is 4 squared. Down here at step 3 down here. Okay. My third step. Okay. 5 squared is 25 plus a squared plus what is 4 squared here? 4 times 4 is 16. Okay. Now, I think what I'm going to do is I'm going to take this over here to the right because it's not showing up well on my screen, at least. All right. So what I'm going to do is I'm going to rewrite what I have at the bottom there. I've got 25 equals a squared plus 16. Okay. Now, I might have mentioned accidentally on a previous slide video that we only have to know just very basic algebra, and this is very basic algebra. But it's just going to be a little bit different step. You remember we want to get the letter by itself in algebra, right? And so to get it by itself, how would you get rid of that 16? Okay, it's a plus 16, right? So if I subtract 16 from this side, and remember in algebra, whatever you do to one side, you have to do the same exact thing to the other side. So I subtract 16 from that side. Okay. So what that gives me is 16. I've got a 9 here. 16 from 25 is a 9. And these two 16s, I'm going to take my pencil or my drawer, I'm going to cancel them out because they're now erased. 16 minus 16 is 0. Okay. So I've got 9 equals what's left? A squared. Okay. All right. So if I find out the square root of 9, what is the square root of 9? A equals, okay, just 3. Okay. And so at that point, a squared, then I'm okay, what is this thing that's squared that equals 9? Basically, I'm really just asking what's the square root of 9? And it's 3. Okay. A equals 3. So that means side A here is 3, in this case, feet in length. Okay. All right. Let's go ahead and take a look at our next slide. And oh, I think that's it for today. So what I want you to do is there should be homework in your textbook. If I haven't mentioned it already, let me just put it on the screen. You're going to do pages 68 and 69. I think we just did page 67 already. But yeah, 68 and 69 of your homework. So that's what I want you to do is all the problems on pages 68 and 69. Um, those are going to put you in a situation where you're doing exactly what I just got through showing you. Let me just double check one thing real quick here, if you don't mind. Um, did something happen to my slides? Nope, that's it. Okay. I have the next session will be a review for your we can call it a midterm exam, but it's just going to be all on triangles.